Okay, so if you're building anything with AI right now, you know it's about way more than just code. It's really about picking the right blueprint for the job. Today, we're going to break down the essential design patterns for AI agents, taking you from the absolute basics all the way to some seriously sophisticated stuff.
So you've got a task in mind for an AI. Great. But how do you actually build it? Do you go for one single, super smart agent that does everything? Or do you build a whole team of specialists? That's the big question, right? And it's exactly what we're here to figure out. Let's dive into the blueprints, starting with the most fundamental one.
All right, let's start at level 1. This is the foundation, the ground floor, the single agent. Think of this as the simplest, most direct way to get an AI to do something for you.
So what is it exactly? Well, with this pattern, you basically hand everything over to one AI model. You give it a goal, maybe a few tools to work with, and then one big detailed prompt. And from there, the agent just figures it out. It uses its own brain, its own reasoning, to map out all the steps it needs to take.
Let's make this real for a second. Imagine you tell it, hey, plan me a trip to San Francisco. You give it access to Google Search, and that's it. The agent is on its own. It starts looking up flights, finding hotels, searching for cool things to do, all in one continuous thought process. It's simple, and for basic stuff, it's pretty effective.
But, and you knew there was a but coming, right? What happens when the job isn't so simple? What if it's a complicated, multi-step task with very specific rules? Well, this is where our simple, single agent starts to, well, stumble a bit.
And this quote really hits the nail on the head. The core issue is that AI is non-deterministic. You can give it the same prompt twice and get two different answers. So when you give it a really complex multi-step job, that single agent might get lost. It might skip a step, or worse, it might decide to get creative when you really needed it to just follow the instructions. You lose control.
So here's the trade-off, plain and simple. On the one hand, this pattern is super easy to implement. It's fantastic for straightforward jobs. But the moment things get complex, you're trading away reliability and control. And trust me, when it goes off the rails, trying to debug what happened in that one giant step is a real headache.
So to solve that exact problem of control, we're going to level up. Welcome to pattern number 2, the sequential agent. This one is all about getting back in the driver's seat and making our system predictable.
The best way to think about this is like an assembly line. Seriously, instead of one worker trying to build a whole car, you have multiple specialists. Each agent has one specific job to do, and they do it in a fixed, predictable order. The output from one agent just becomes the input for the next one down the line.
Let's go back to our San Francisco trip. Let's say your task is to find a late-night sushi spot and then find the fastest way to get there. Using a sequential pattern, you'd have two specialized agents. First, the food-finding agent does its job. It finds the perfect restaurant. Only after it's completely finished does the transportation agent wake up and use that restaurant's address to find a route. Step 1, then step 2. Simple.
Okay, that's cool, but how does that second agent know what the first agent found? How do they talk to each other? Well, they use this really simple but brilliant little mechanism called a shared scratchpad.
You can literally think of it as a digital sticky note. The first agent finds that sushi restaurant and just jots down the address on this shared scratchpad. Then, when it's the second agent's turn, it just looks at the scratchpad, reads the address, and does its job. It's a simple, short-term memory for the whole system.
So what's the strategic choice here? Well, the pros are huge. You get a massive amount of control and reliability. The whole process is way more predictable. But the downside? It's inflexible, it's rigid. This assembly line is going to follow the same steps every single time, even if the situation changes. It just can't adapt on the fly. But what if your tasks don't actually need to be done in a specific order? What if your biggest enemy isn't a lack of control, but a lack of speed? For that, my friends, we turn to our third pattern, the parallel agent.
The whole idea here is to crush latency, the time you're sitting there waiting for an answer. If you can break a big job down into a bunch of smaller tasks that don't depend on each other, you can have a whole team of agents work on them all at the exact same time.
Think about planning a full day out in the city, finding a cool museum, checking for concerts, and looking up top-rated restaurants. None of those tasks depend on each other, right? So why would you do them one by one? With a parallel system, you'd have a museum finder, a concert finder, and a restaurant finder all running at the same time.
So this pattern is really like a two-step dance. Step 1, you unleash all your specialist agents at once. They all go off and do their thing in parallel. But then, and this part is absolutely crucial,
you need a final aggregator agent. Its only job is to take all those separate results and cleverly weave them together into one single coherent plan.
So what's the fine print on this one? The pro is a knockout. It is fast, like significantly faster. But the cons are real. First, it can cost more upfront because you're spinning up multiple AI agents at once. And second, it adds a layer of complexity because you always need that extra aggregation step at the end to make sense of everything.
Okay, so we've just walked through 3 incredibly useful patterns. We have the single agent for simplicity, the sequential agent for control, and the parallel agent for pure speed. The biggest takeaway here should be that there's no single best one. It's all about choosing the right tool for the job you're trying to do. And this right here, this is basically your cheat sheet. It lays it all out. If your task is simple and you need maximum flexibility, the single agent is your go-to. If you have a structured process that needs to be perfect every time, you need the high control of the sequential pattern. And if you've got independent tasks and just need to get an answer back as fast as humanly or AI-ly possible, parallel is your champion. This is the chart you come back to when you're designing your next system.
Now, with just these 3 patterns, you can build some amazingly powerful and sophisticated systems. But here's the kicker. This is just the beginning. The next frontier is stuff like self-correcting agents, systems with dynamic routing that can choose their own path, and even agents that use other agents as tools. So the real question isn't just which pattern to use today, but how are we going to combine these patterns to build the truly intelligent systems of tomorrow?